Hi everyone, I'm Darya Vinogradova, Senior Computer Vision Engineer from Yandex, and today I'm going to tell you about music control with gestures, which my team and I developed for Yandex Alice. Firstly, please raise your hands who has even heard about Yandex Alice. Not pretty much, so I think I need to introduce her. Alice is a voice assistant developed in Yandex, and she lives in different devices, for example, speaker boxes, smart home devices, or browser. But in all these cases, Alice is actually blind. She can hear you and she can speak to you, but she does not see something around her. And in the previous year, Yandex released a completely new device, which has a screen and a camera, and this camera is like eyes of Alice. So now our voice assistant can see the world around her, and we as a computer vision team got plenty of nice tasks to implement. For example, user recognition, detection of users' attention, or some proactivity based on it. But today I'm going to tell about one of these features. It is music control with gestures. And now I want to show you a small demo how it looks like and how it works. So as you could see here, my colleague shows her hand to the device, and the music stops and then plays again. So that was this feature. And you could think that it is pretty easy task in 24th year, just some detection and classification over it. But I think the obvious problem for every machine learning task is lack of data. And we needed labeling for the exact set of gestures in our task. But all the relevant data sets had bad quality or restricted license. Also, collecting photos by ourselves was too expensive, and the lack of data was a real problem for us. The second problem was our device. It is really low power, and all the models for it should be really lightweight. Secondly, only in-state quantized models could be inferred in factory on our device, so it was a pretty hard task to prepare your model for inferring on it. And in the first release, there was no our own model on this device. It was a model from Google Media Pipe, some model developed in Google which can recognize gestures. And this model was really fast, just 40 to 50 milliseconds per iteration. And it recognized hands pretty well in a distance like 1.5 meters. But when the distance was further, it worked really worse. And also, it supported just custom set of gestures, and we wanted to have our own set and maybe expand it in the future. So we decided to make our own model for this device, and our goal was to be better than Google Media Pipe. So what is be better than Media Pipe? Firstly, it is speed, because Media Pipe model is really fast, and we wanted to be as fast as it. Also, we wanted to have a bad quality, have a good quality on our own benchmarks, and there was different benchmarks. Firstly, YouTube videos. We wanted to have low false positive rates on these videos. And the second type was the data which was collected with Yandex respondents. We asked them to show gestures in different distances, and so we wanted to have good precision and recall on these benchmarks. And all this data was collected with humans, so their faces are hidden these cute seals. I believe you like them. So, as I said before, all the open source data had bad quality or restricted license, so we decided to collect our own data, not very many examples, but we collected this data from 5,000 participants and asked them to photo 6 different gestures. Then we collected these photos, we applied some automatic labeling process. We labeled these photos with Google Media Pipe and some heuristics based on our own models connect with people, for example, face detection, body detection, etc. Okay, we got this data and then we trained our first model. It had a mobile native V2 architecture and SSD model for detection. But results were quite ambiguous because we had more false activations comparing to MediaPipe, and our distance was too low because we wanted to recognize hands and gestures well in 3 meters, and this model recognized them like MediaPipe in 1.5 meters. And also our model was pretty slow because when we tried to convert it to device inference format and then quantize, we lose a lot of accuracy. So we just inferred it in CPU, not in PU, and it was very slow compared to MediaPipe. Then we started to think, how can we improve our model? We saw that model didn't perform well on unknown domains, and the obvious way to fix it was to get more data, but how if it is pretty expensive? And in this moment, we thought that we could organize some pre-training stage and collect more data, make this pre-training on it, and then tune on our clean data. But stop, we can easily mine detection labeling with, for example, Google Media Pipe, but we had our own set of gestures, so how can we mine the both labelings? And then we decided to divide our detector and classifier and train them separately. So we could make our classifier a very lightweight model with quantizable architecture, so our overall pipeline wouldn't be much worse than previous. And our detector could be trained on some dirty data labeled with MediaPipe or something else. Okay, we made this decision, and then we started to mine our data for training the hands detector. We had 3 methods of it, and the first method was with visual search. So we searched some similar images for every image from our data set. Then we labeled the hands with Google Media Pipe and get the kind of dirty labeling. This kind of data is really infinite because we can scrape images from the internet really infinitely, but it also had a disadvantage that we could get some irrelevant images because the visual search is not ideal, even in Yandex. The second way was with using of generative models. We found that stable diffusion could be predefined on human skeleton, and this way we could predefine this model and get images of people with very diverse poses. So we make this skeleton labeling with hand key points for our data, and then generated a lot of images with stable diffusion. This kind of mining was also nearly infinite, and poses were diverse because we applied augmentations for our data and get really diverse skeletons. But you know, generative models can produce a lot of artifacts, like this handsome man with 6 fingers, and it is not the worst artifact you can see from generative models. And also, these images are non-realistic. They look maybe like cartoon, but not like photos of real persons. And the third way was, again, with crowdsourcing labeling, but it was another task, classification, not collecting photos, and it was much cheaper. So we mined a lot of photos with people, and we asked our respondent to answer the question, are there any hands on these photos where our model found them? And also, if are the gestures predicted correctly on these photos. So we got this classification labeling, and it was really cleaner than comparing to the previous data, and it was relevant to our task. But this data was not infinite. It cost money because it was, again, labeling cheaper, but it cost money anyway. Okay, so we combined it all together and trained our detector on the mix of dirty and clean data. We saw that it really learned more useful things about the world, but unfortunately useless too, because we had plenty of irrelevant or dirty data with artifacts. So our detector could detect hard examples, but it produced a lot of false triggers too. But we also trained a classifier. It was trained on the clean data with hard augmentations, and we made it really lightweight, just 6 milliseconds on the device per iteration. And we also saw that we could filter the bad detections with our classifier, because it was trained only on the clean data, and it could distinguish crops of the hands or some other false crops. So we solved the problem with quality, because these two models together worked pretty well. And the only problem which remained was performance. So our bottleneck was a detector, because our current architecture could not be quantized effectively, and we lose a lot of accuracy with it. So we needed to train something smaller and also quantizable for our device. And we found such a model. It was YOLA V8, pretty slow and also quantizable model. And the authors used some specific activation while training and produced just raw features and output. So this model could be quantized effectively for our device, and we just took it and trained on our data. And here you can see the results after our experiments from the first model just on the data from our respondents to YOLA V8 detector, which was trained on the mix of dirt and clean data. And so we achieved better results than Google Media Pipe in all the metrics. So we produced less false positives on YouTube videos. We had bigger true positive rate and a lower false positive rate than MediaPipe model. We were as fast as it, and also our distance was even more than target. Our target was 3 meters, and we got 3.5 meters, so it was actually winning. Okay, and now let me make a small conclusion about all the story. The first thought is that simply the first class task could be very hard on the real world domain, but nowadays there are a lot of ways to mine free data for your training, and don't be afraid of synthetic data, it is very useful. The second thought about specific devices. It may be very difficult to adapt your model for your device, but you really have no need in complex end-to-end pipeline. You could divide it to several simpler models, and it could work pretty well. Also, it is useful to find the specific architecture just for your device. If your conversion is hard, then maybe this architecture would be more suitable for you. And that's all. Thank you very much. I would be glad to answer your questions.
Do we have, yes, we have one question here.
Thank you for the presentation. What are the most difficult gestures?
I think the most difficult gestures were this and this one. But now we don't use them in production because we decided to make some dynamic variants of these gestures, swipes left and right, and now we're working on it.
So, yeah, like nice talk, thanks. Like I'm interested, like why you needed to develop the model that is working on edge on device, because like most of this, like a Google smart speaker, they usually send something to the cloud and then like process it there on GPU, and they can use then like larger models and don't have a lot of problems that you described. So yeah, like I'm just interested, what was the reasoning, why it needed to be executed and inferred on device?
Because it is always cheaper than you make some small models which could be inferred very fast. And I think it is not effective to use GPU for this task if we really can make everything on our device. And the second reason, I think, is real time. We recognize the gestures on the device in real-time mode, and it is very important for us.
No more questions for Darya. Darya, thank you very much for joining us today.
Thank you.
This is for you, courtesy of the organizers. Thank you very much.
Thank you.